In this video, I am going to demonstrate you how to perform superposition theorem for this electrical technology lab. So again, you have to be very familiar with the theory of superposition theorem before performing this experiment. So if you are not aware of the theory, please revise the theory before going further. So now we are going to have a look at this circuit diagram for the superposition theorem. So as you can see in this diagram, we have two different sources. One is 220 volt, another is 110 volt. And as you know the basics of superposition theorem, so if you look at this circuit, we have these two sources, 220 volt and 110 volt, and we are going to see these three currents that are flowing in the circuit, I1, I2 and I3, under three different conditions. So in the first condition, we are going to see how these currents looks like when both the sources are active together, and in the second case we are going to take a look when only 220 volt source is active, where this 110 volt is short circuited, and in the third case we will see effect due to this 110 volt, whereas this 220 volt source will be short circuited. One important point to note here is that the direction of current is very important for this experiment, because as you can see, the current that are flowing through those emitters A1, A2 and A3, they can be positive as well as negative. So we need an emitter which can sense current in both the direction, and it can tell us whether the current is positive or negative. So for doing that, we need a special type of emitter. So as you can see on your screen, we have two different type of emitter. One is known as MI, another is known as MC type. What is MI? MI is moving iron and MC is moving coil. So if you look at their scales, it will be quite clear to you that for the AC type of emitter, which is MI, initially the scales are very dense, and if you look at the later part, they are quite uniform. And if you look at the scale of an MC type instrument, you can see the scales are uniform. And another distinct difference is that both the positive and negative direction of current can be observed from this display. So you can see the 0 is at the center position, and on the right side we have positive display for current, and on the negative side it will show you if the current is going in a reverse direction. But for the MI type instrument, you can see the 0 is on the left side, so it will give us current in only one direction. So basically this is used for AC, where it will give us the RMS value of the current, and for AC we are not interested to get what is the current direction, because current direction will be changing in every half cycle. So now we are going to see how to make the connections and how to arrange all those instruments to perform this experiment. So as you can see on the circuit diagram, we will start with the left side. So we have a 220 volt coming in, and then we have a DPDT. So this is this DPDT. So on one side of the DPDT, as you can see, it will be short circuited, which is BB side. So this is the BB side and this is short circuited. So this side is short circuited, and on the other side that will be connected to the 220 volt supply, and that will take from our power supply board. So as you can see on the right side, it is the 220 volt, and on the left side it is 110 volt. So from the right side, which is 220 volt, we are taking this power supply and we are bringing in to this DPDT, and on the other side of the DPDT, this is shorted, and from here we need to connect a rheostat which is 85 ohm, and we will be connecting to the variable point. So let us see, if we take the positive terminal, and we take a red wire from that and we connect it to the variable point of the rheostat, and from the fixed point of the rheostat, which is this one, we will be connecting it to the emitter A1. So, as you can see, we have connected the common terminal and we are keeping the common terminal this side, and after this emitter we will be having two branches. So, one is going to this rheostat, another is going to this rheostat. So, let us see. So, as you can see, in this emitter we have two wires. So, one of them will be going to the rheostat, which is this blue wire, and the other one will be going to the other rheostat, which is this yellow wire. So, both of them are going to the rheostats, and from other part of the rheostat, so as you can see, from this rheostat it is connected to an emitter, this rheostat also it is connected to an emitter, and after that on another side of the rheostat, which one is this 50 ohm rheostat. So, if we look at this, which one is 50 ohm? So, this you can see it is a 50 ohm rheostat. So, from another side of the 50 ohm rheostat we will be connecting to our DPDT. So, as you can see, from the other side of this 50 ohm rheostat we will be first connecting to an emitter, which is A2. So, this is the emitter which is coming from this 50 ohm rheostat, and after this emitter we will be connecting it to the DPDT. So, the other part of the emitter, so one emitter terminal is getting connected from a wire coming from the rheostat, and the other terminal we are taking one more wire and we are connecting it to the DPDT as per this diagram. And in this DPDT, one side will be shorting, this side is DD side. So, as you can see, this is the DD side. So, here we are putting a short, and on the other side of the DPDT we have 110 volt to be connected. So, on the other side of the DPDT you can see we have two wires and they are finally connected to our 110 volt supply. So, this is how the entire circuit arrangement is done and the circuit is complete. And one thing I am repeating in this experiment, the emitter that we will be using, they are MC type emitter, where we should have provision to see the current in both the direction, right. So, as you can see, in the middle emitter we have the 0 position at the midpoint, and we can see both negative as well as positive current. Similarly, on this emitter 0 point is at the midpoint, so you can see current in both positive and negative direction, and this is also correct for the third emitter. So, while choosing emitter for this superposition theorem, you have to be careful. So, now we are closing the switch S1 and we are connecting it to the AA side, and we will do the same thing with the switch S1 and we will connect it to the CC side. So, as you can see, now both of them are connected and both the power supply 220 volt and 110 volt, they are now active and they are connected to our main circuit. So, with this you can see the readings on the emitters. So, on the first emitter you can see there is some positive current flowing. So, we will note down that reading. On the A2 there is again some positive current is flowing, and on the A3 we have again positive current flowing. So, we will note down those readings and we will tabulate them in the observation table. So, as you can see, there is a place for noting down those numbers. So, we will note them down for the first set of readings. So, this will give us I1, I2 and I3. So, now we will be going to the next step and we will place a short circuit on this DPDT S2 side. So, in the first set of readings we had connected this DPDT such that this 110 volt was connected to the circuit, and now we will be replacing this 110 volt by a short circuit. So, we will be replacing this source by a short circuit by placing your DPDT to this DD position. So, which we have done now, as you can see. So, initially this was connected to that side and 110 volt supply was connected. Now, we have shifted it to this side. So, it is connected to a short circuit path. So, basically it is not the case that we are short circuiting a voltage supply. We are just removing the voltage supply, and instead of that voltage supply we are placing a short across it. So, in the circuit now we have only one active source, which is this 220 volt, and under this condition we will again note down what are the readings of the emitters. So, as you can see, in the first emitter we have some positive reading, on the second emitter we have again positive readings, and on the third emitter we have positive readings, but definitely this currents will be different than what we have seen in the first set of reading. And using these three readings we will again, these three readings we will formulate, we will note down in our observation table under I1 dash, I2 dash and I3 dash, and after that we will go to step 3. So, now we are going to the step 3, where we are bringing in that 110 volt supply again. So, this position, as you can see, it has been shifted to the CC side, and 110 volt supply is now given to the circuit, and on the DPDT 1 we will, instead of applying 220 volt, we will be applying a short. So, the 220 volt we are replacing by a short circuit as per this basic diagram, as you can see in this third diagram. So, right now only 110 volt supply is there in the circuit, and 220 volt supply is removed, and instead of that we have connected a short circuit. And in step 2 what we had done, we had kept only 220 volt, and instead of 110 volt we had replaced that by a short circuit. So, now we are in step 3, and we are seeing current due to 110 volt source. So, now if I look at this emitter 1, you will see that the current has gone negative. So, now I believe you have understood why we need a emitter which can give us both positive and negative direction of currents. So, we will note down this current, and we will note down the other current. So, here you can see it is still on the positive side, and this is the third emitter where you can see current has gone to the negative side. So, again we will note down these three readings, and we will write down their values under this step 3 here, I1 double dash, I2 double dash and I3 double dash. So, this is how one set of readings will be done, and you can calculate some values, and you will be comparing experimentally obtained values and theoretical values, and you will be figuring out what is the error. And then in the next step we will be varying the rheostats, and we will be repeating these steps again for different set of resistance, and there you can take few readings, and that is how this experiment will be done. And after that, of course, you have to submit a report along with all these observation details, your conclusions and answer to the discussion questions. So, with this I am concluding this superposition theorem. I hope you have understood how to conduct it, and it will be useful for you. Thank you for watching this video.